Picture this, two atoms sharing electrons, creating a bond that is both strong and stable. This is a covalent bond. In the world of chemistry, covalent bonds are formed when two atoms share electrons, helping them to achieve a stable electron configuration. It's a kind of partnership where atoms come together to share what they have, creating something much stronger than they could be on their own. So covalent bonds are like the best friendships. They share and create strong connections. Now, not all covalent bonds are created equal. They come in three main types: single, double, and triple bonds. Let's start with single covalent bonds. They're a bit like a dance between two atoms, where each atom brings one electron to share. A great example of this is the hydrogen molecule, where two hydrogen atoms share a single pair of electrons. Next up, we have double covalent bonds. In this case, each atom brings two electrons to the dance. Oxygen molecules are perfect examples of this. Two oxygen atoms join hands, or rather electrons, and share two pairs of electrons. And finally, the triple covalent bonds. This is where things get serious. Each atom brings three electrons to the party. Nitrogen molecules are a classic example here, with two nitrogen atoms sharing an impressive three pairs of electrons. But how are these bonds formed, you ask? Well, it's all about sharing. Atoms form covalent bonds to achieve a stable electron configuration, and the number of electrons they share, be it 2, 4, or 6, determines whether the bond is single, double, or triple. So, as you can see, covalent bonds are all about sharing. And just like the number of friends you can share with varies, so does the number of electrons atoms can share. Each type of covalent bond reflects a different level of sharing, and thus, a different level of strength and stability for the molecule. Just like the number of friends you can share with varies, so does the number of electrons atoms can share. Apart from the main types, there are also polar and non-polar covalent bonds. Delving into these, a polar covalent bond is a type of bond where electrons are shared unequally between two atoms. This happens when the atoms have different electronegativities, that is, different strengths of attracting electrons. Think of water, or H2O. The oxygen atom is more electronegative than the hydrogen atoms, so it pulls the electrons closer, creating a slight negative charge on itself and a slight positive charge on the hydrogen atoms. On the other hand, a non-polar covalent bond is where the electrons are shared equally. This happens when the atoms have the same electronegativity. Methane, or CH4, is a good example. The carbon atom and the hydrogen atoms all share the electrons equally because they have the same electronegativity. So, whether the electrons are shared equally or not, it all depends on the atoms involved. Covalent bonds in their many forms are fascinating and integral to the world around us. We've traversed the terrain of single, double, and triple bonds, each unique in their electron sharing capabilities. We've also discovered polar and non-polar covalent bonds, where electronegativity plays a critical role in defining the nature of the bond. Each of these covalent bonds, whether they are single, double, triple, polar, or non-polar, holds a special significance in the grand scheme of chemistry. They are not just theoretical concepts confined to textbooks, but they actively shape our world, from the air we breathe to the water we drink and beyond. Understanding these bonds is a stepping stone to unraveling the mysteries of chemistry. The knowledge of these bonds opens up a world of possibilities, from designing new materials to understanding biological processes. So let the journey not end here. Dive deeper into the world of covalent bonds, explore more, and uncover the wonders of chemistry.